There's also there's no stop box because I couldn't get that together with everything going on in today's notes. So we are not going to have a stop box today. We are going to talk about factorization and simplification. Alright, let's stay focused. Today's definitely a day we want to stay focused and pay attention because it's factoring, and we know that factoring can be a struggle. We're not just factoring, we're also going to be doing some simplification, and with the simplification, we're going to kind of take some of those laws that we use and use them in reverse. So you can, I apparently need to realign this, it got a little bit crazy, so I'm going to do that. But we're going to use some of those laws in reverse as well as doing some factoring, and we're going to talk about a variety of ways. Okay, so remember we had this rule where if I had like a over b to the m, what would I do with that m? Distribute to both of them. So that'd be a to the m over b to the m. Well, we're going to go the other way. So we might have something like this, and we might go ahead and kind of pull that m out and write it like a fraction. So we're going to kind of go backwards on a few of them. That's going to actually be towards the end of the notes when we do that. Another one that we can also use is if I have a to the m times a to the n. What did I do with those exponents? Add them up. So we're actually going to, again, kind of go backwards. We're going to take something that was added and then split it up into two different, not two different bases, but two bases. So we're kind of going to be using some of those laws backwards in addition to doing some of the factoring stuff. So those are some of the stuff we've already done. We're going to look at it with factoring. So do you guys remember like factoring out the greatest common factor? We're going to do that first. We'll be okay. I hope we'll be okay. I think we'll be okay. Yep. So here I have 5 to the 2x plus 5 to the x. So when we look for greatest common factors, we're going to look for things like the same bases. And I see that I've got 5 in both of these. I mean, this isn't quite 5 to the x. It has an x, but I've got 5 in both of those, right? So I'm going to take maybe an extra step that you guys might not take as often as we move forward here, but how could I split this up into two different things so I have 5 to the x? So like, if I want to get this as an x plus what is going to give me 2x? So it's kind of a little bit weird, but kind of thinking about that, like I said, we're kind of going in reverse because I'm going to rewrite that second half. And now what we can see is that we've got 5 to the x in both of those. So that's my greatest common factor because both terms have 5 to the x power. So I can pull that out and have 5 to the x power. So when I take that out, what's left over here? Right here, there's 5 to the x. And then over here, it's just 1. So I can slow that down if you guys can't see that. I'll redo that. I'm going to give you guys a chance to write that down, but then we'll redo it. I just said, if you listen, I said, all right, let you write that down, and then I'll go over it again. So if I look at both of these, I can see that they both have 5 to the x. So I can take out 5 to the x, and I'll have something in parentheses. Now, if we're not sure, we can actually show that like a division. So I've got 5 to the x and 5 to the x. That's this. I just rewrote this. But I'm taking out this. So when I take that out, what's left? to the x. And then same thing, I've got 5 to the x, and I'm taking out this 5 to the x. So what does that simplify to be? Just 1. Because it cancels out, but we got to hold that spot. So that's definitely something that when I originally teach freshmen how to factor, I have them take this step because they have a harder time seeing it. So if your guys are feeling like, you know what, this looks so weird, this looks different, this looks new, you can take that extra step if you're not sure what's left. There's nothing wrong with that. Like, that's a really good strategy for yourself if you're not seeing it. Go ahead and write that down because then you can see what's left. So we're going to take a look at another one like this. It's a little bit different. So I've got 3 to the n plus 1 plus 27. What's different about this one compared to the first one? Yeah, they don't have the same base, right? Because that's a 3 and that's a 27. So your first step would be, let's get them to be the same base. And remember, it's usually 2, 3, 5, or 7. What are we going to use in this one?
3.
So I'm just going to go ahead and I'm going to leave this for a second. But I'll change this to 3 to what power? The third. So first things first, get the same bases if you don't have them already. Are we okay? So now, I know that I can kind of change this. I know it's n plus 1, but kind of the step before it would be 3 to the n times 3 to the 1. You know how we talked about we're going to work that in reverse to kind of see our factors? So I kind of worked that in reverse to see my factors. But I got to do something to the other side. Some of you might see it. If not, we're gonna write it down so we can all see it. Because there's no way for this 3 to turn into an n, right? But can I somehow get 3 to the 1 out of this? Yeah. What can I do?
3 to the 1 times 3 to the 1.
Yes, but I'm gonna just do 2, so I don't have so many of them. But yes, that's true. So I kind of am thinking, okay, I cannot make this into an n, but maybe I can get a 1 out of it because 2 plus 1 is 3. So we're kind of working some of those laws backwards. So to get that 1, and now what happens, I just didn't write my plus sign at first. Do you see we have a common factor here? Yep. Now before I finish it, do you guys want me to slow it down like I did the last one and cross them out? I have some yeses and some no's. So if you're a no, go ahead and write the answer down. So then I'm going to write it down here. So 3 to the first power, and I've got something. So I'll have 3 to the n times 3 to the first, but I'm dividing it by 3 to the first power because that's what's out here. So when we cancel that out, we've got 3 to the n power. And then when I do the other side, I've got 3 to the second power times 3 to the first power, but divided by 3 to the first. So then the 3 to the first cancel out, so all I have left is 3 to the second power. So again, if you're having trouble seeing what's left, then you can take this extra step here to kind of see what should go into your parentheses. That's good, because we're factoring, so that's good. Yes, yep, we're taking that greatest common factor and putting it out, so that's what we've got right here that's the same, so that's coming out front. And then that's what we divide by. Okay. We're going to switch gears to some other types of factoring unless we have any other questions on this one. So then the next type is a little bit different, and it's a little bit different when we do this with normal numbers too. I got 4 and I got 25. Well, 4 to the x power minus 25. At first glance, it kind of looks like there's nothing similar about those numbers. Yes, they're both perfect squares though. So another thing to kind of keep your eye out for is if you have perfect squares. Now, I don't know if you guys remember, we had talked about yesterday, so you don't necessarily need to write this down, but you can if you want to. We had talked about how if we had a minus b times a plus b, the shortcut is a squared minus b squared. You guys remember that? So that's what's kind of, we can use that here. Because if this is a perfect square and that's a perfect square, then I know my answer will be these two binomials with the same numbers but different signs. So I'm going to leave that up for just a second, but let's kind of take a look. So if 25 is a perfect square, it's what number squared? 5. Okay, so 5 squared. So it's kind of like 5 is b. You guys kind of seeing that pattern so far? Okay, what about 4? Okay, so I've got 2x squared. I know that's a little bit of a jump.
Wait, but when you multiply the x by 2,
so then that'd be 2 to the 2x.
Yeah, that's what I'm asking.
Which is 4x.
Oh, okay.
I'm so glad you said that because it looks great when we write up here. So this is the same as that. So you kind of see how we went?
Mm-hmm.
Way to bring that up. So now I'm going to erase this, but this 2x is like in my A spot, so I'm going to use those two numbers when I write my answer. So I'll have 2 parentheses, so I've got 2 to the x and 5, and 2 to the x and 5, and then one's plus and one's minus, doesn't really matter which goes where. So while that shortcut is pretty unnecessary like yesterday, it's very, very, very helpful here, and I do recommend using it here. And I'm going to let you guys try that out on your own on the next one. So kind of look for those perfect squares. So try the same thing. Look for those perfect squares. We all get it already? So 9's a perfect square. What would that be?
3x.
And then what about 49? And I'm going to be honest that you don't have to take that step. Like if you can see it, you can jump to the answer. I'm not going to force you to show work on that, but I want you guys to see where it comes from. Because then now we've got 3 to the x minus 7 and 3 to the x plus 7. Again, the plus and minus doesn't matter as long as we have one of each. Are there any questions? Okay. So all day long I've been kind of teaching this next part the long way, and then my students have been saying, why are you doing that? Don't even do that. So I'm going to see if teaching this the short way actually works better, okay? So we'll see what happens. If it doesn't work, I'll back it up and then I'll go for the long way, okay? Now I know this looks crazy. I'm going to try to take the craziness out of it. 9 to the x power plus 7 times 3 to the x power plus 10. So let's kind of talk about something similar to this. Like, if you saw this problem, if you saw x squared plus 7x plus 10 in the direction said factor, what would you do for this problem? Okay, x plus 5 and x plus 2. Yeah. These are like the same problems. We want to know what's different. is instead of x, it's 3x. I know you can't see that yet here. I'll show you why that's true, but it's basically the same thing. So I don't want you to panic, because if you can do the same thing, if you can think of factors of this number that add up to this number, you will be completely fine. Now let's see how this works. Let's make more sense. So the first thing you want to do, like we've been doing before, is you want to take this 3 to the x and you want to make 9 have the same base. So how could I make 9 have a base of 3? Yep. 3 squared, so I'm going to write 3x squared. So that's kind of like the first thing that we do, and I'm writing that there to kind of show you what's up. Because that's why that one was like the 3x squared, like it was the x squared that I had before. Then the next thing is that we have to think of factors of 10 that add up to 7. Yes, I planned it to be the same as that other one. So 5 and 2. So 5 plus 2 equals 7, and 5 times 2 equals 10. So the shortcut way is that here I go, my parentheses, I'm going to have plus 5 and plus 2. We know where those came from, right? And then this 3 to the x is what goes in the front. Now there's a longer way with a bunch more steps that I can show you and explain it to you, but I don't know if that's going to be better or worse.
Maybe you have it.
Okay. We're going to do another one like this. Is there any other questions here? Since we've, yes.
So no matter what number is where the 9 is right now, you don't worry about it and you just find something that multiplies to whatever c would be?
Pretty much, because whatever's here should go with this. If it doesn't, I don't think that would be factorable.
Okay.
I mean, it would be worth it to check to make sure that it's like 5 and 25 or 7 and 49 or something like that. It'd be worth it to check, but yeah, pretty much.
Okay.
All right. Now this next one has something else that looks a little different, but it's really not too crazy. 4x minus 4 to the x minus 2 to the x minus 20. So, yeah, kind of like what we were just talking about is that I can write 4 to the x as 2 to the x squared. Right, so we know that does work out. Like, take that little check. But okay, factors of negative 20 that add up to what? What's there?
-1.
A negative 1. So if you need to, put parentheses and draw that 1 in. Like, seriously, that's going to help you out, and it helps me out. That's why I'm giving that tip. It helps me out, so that's how I write it, so I know what I'm looking for. So now I need factors of negative 20 that combine to equal negative 1. Good, so I'll have negative 5 and 4. And then what goes in the front of these? 2 to the x. Okay, good. Well, there's 2 more examples, but this is it for this. We have to do like the dividing simplification ones, but they're like okay. Okay. Questions here. So, like how I started with, I said we were going to come back to that at the end, is we have to factorize or simplify these guys here. So for this first one, I've got 20 to the x power over 2 to the x power. We should notice that they both have an x. So we're actually going to kind of recombine it. So I'm going to have 20 over 2 to the x power. So kind of working that backwards. Remember how I said that at the beginning? Working that law backwards. Well, okay, so if I can simplify it a little bit more, right? It's 10. So I can take this and simplify it to 10 to the x. I mean, would you guys agree that that's simplified?
Yes.
So again, like we're working some of those laws backwards today. Why, again, it's so important that we have memorized those from 3B. For this one? Yeah. Now for this one, this is another thing I always get a kick out of, like stuff that I teach in algebra and how it like comes back up 4 years later. We were just teaching our algebra kids how we can split that up into like 2 fractions. So it's like 2 to the n over 2 to the n plus 12 to the n over 2 to the n. So how we can kind of split that up into 2 different fractions.
Can you just do one? Right?
Oh, yeah,
Just be one,
sorry.
right?
Yes.
Okay.
I was just like, my brain was not as far as your brain was, so it took me a second. So 2 to the n over 2 to the n equals 1. I'm gonna go slower than that, but yes. Because here I can do the same thing I did here, so I've got 12 over 2 all to the n. And then 12 over 2 does simplify to 6. So I have 1 plus 6 to the n.
Do you have to write it like that?
Yes.
Wait, why
Yes.
can't it be like 7n? What?
Because this doesn't have an n, and even if it had an n, they don't have the same base, so we couldn't put them together.
But couldn't you write it as like you wrote the other one off here? Because they're all
No,
multiplied
because
together.
that plus sign changes that.
Okay.
That plus sign changes that. We can't split that up that way. Good questions. I want you to remember this. Okay? Just you. Okay. All right. Any other questions? Okay, that's it. There's no stat box. That would be nice, but we need practice, so it wouldn't be nice.
Yeah, but there's a lot. It's not that hard.
So, we've got a bunch of time to work. For some reason, all my other classes were like, I'm out, I'm done. And I'm like, please do your homework. I don't know how else to say it. Please practice. Get better at math by practicing. Okay, that's my plea.
When we go over,
That's your plead.
Yeah.